Okay, so now we'll have a look at some questions that's not our binomial theorem, like our algebra, but we'll have a look at this binomial distribution. So in this case, your log tables should be open on page 33. So if you're looking at page 33, I'll just rewrite it for you. You should be looking at n choose or, p to the power of or, q, n take or. Now, in this case, p is going to be seen as our success, q is our failure. And just notice that this is the bottom, and then n take or is top minus bottom. So it is different from the binomial theorem in that way. Okay, so how would we even know in an exam that this is what we're supposed to be doing? So a student answers 3 multiple choice questions, each with 5 possible answers. So if you can imagine a test where you've 3 questions and then you've 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So there's 5 possibilities for each question. The student knows none of the answers and guesses each time. So they go to question 1, guess, go to question 2, guess, go to question 3, and guess. What is the probability he will guess 2 out of the 3 correctly? So in other words, we're saying it's 2 out of 3. So it's 3 choose 2, basically. So we want to know what is the chances that 2 of them out of the 3 will be right. Now, usually in the first position, we put the possibility of success. Now, the probability of success in this case is 1. There's a 1 in 5 chance, because every time this person guesses, they have a 1 in 5 chance of getting it right, which means the probability of failure is 4 over 5. So we put the chance of success there and the chance of failure there. And it is only success or failure. And this is what we call the Bernoulli trials. There isn't another option. It's a kind of a win, lose, succeed, fail. You know, there's no such thing as anything in the middle. Like if this was a match, we would be saying win or lose. We would be excluding the idea of a draw, for example. So each of these questions are Bernoulli trials. There is only one or the other, success or failure. So what do I do with the powers? So I follow my formula. So because 2 is on the bottom, the 2 goes there. And because 3 take 2 is 1, 1 goes there. And it kind of makes sense then, because what you're saying is that you're doing a power of 2 for the success, because he's guessing 2 out of the 3 correctly. And then there's 1 chance of failure. Now that's it done, because now it's just calculator. 3 choose 2. That's 3. 1 over 5 to be squared is 1/25, and then 4/5. So you can use your calculator to do all that anyways, but just showing you each step there. So we are getting an answer of 0.096. Okay, 5 unbiased coins are flipped. Find the probability of getting 3 heads and 2 tails. Now, again, this is a Bernoulli trial because there's only 2 options, heads or tails, just like success, failure. Now, you kind of have to decide which one's success. So I'm just going to say success is getting heads. So I'm going to say the probability of success is 1/2. Now, failure means not getting ahead. So you could say tails, but not getting ahead is also 1/2 a chance. So from my 5 coins, I want to know the probability of getting 3 heads. Now you might say, well, what about the rest of the sentence? Well, it doesn't matter, because if I've gotten 3 heads, I automatically have 2 tails. Do you understand? Because there's only 2 options, heads or tails, nothing in between. I write my chance of success here, which we said was 1/2, my chance of failure here, which we said was 1/2. And then I follow my formula. That's going to be 3. That's going to be 2. And again, then I just put it into my calculator from here. So that's 10. That's 1/8. And that's 1/4. So 10 by 1/8 multiplied by 1/4. So that's coming out to be 5/16. And if I want to change it to a decimal, 0.3125. A couple have 6 children. Find the probability that they have 4 girls and 2 boys. Now, this is a Bernoulli trial because, again, if it's not a girl, it's a boy. If it's a boy, if it's not a boy, it's a girl. There's only 2 choices. Bernoulli trials are when you only have 2 choices. So this is exactly 2 choices here. So it's Bernoulli trial. And if it's a Bernoulli trial, then we can use the binomial distribution. So you have to decide at the start what is success. So we're going to say the probability of having a girl is success. So in this case, having a girl is a half a chance. And then the probability of failure, having not a girl, a boy, is a half a chance. So a couple have 6 children, find the probability. So out of 6, the probability they have 4 successes, success being having a girl. Then I write down success, I write down failure, and then I copy my formula from page 33. The bottom number goes there. 6 take 4 is 2. So just be careful that you, again, are looking at the right page. So there's the binomial theorem, and then there's the binomial distribution. So this is the one on page 33. So now we have a half to the power of 4. So that's 1/16. And this is going to be 1/4. So now we're going to multiply those together. 15 by 1/16 by 1/4. And that's giving me 15/64. And as a decimal, 0.2344. Usually for probability, we do 4 decimal places. Okay, so I'm going to end the video there and I'll do another one.